Hello boys and girls, today we're going to take a look at variables. Just remember, when we're dealing with variables in mathematics, they're symbols that represent unknowns. Okay, we use variables to help us solve different mathematical expressions, and we can substitute different mathematical values, or we would even say quantities, for these symbols. Let's take a look at some sample problems and begin. Thank you. Boys and girls, today as we look at variables, we're going to look at them in their natural setting. And we'll often find variables, most often in algebraic expressions and equations. So here we have an algebraic expression, 3x to the fourth power minus 2y, and all of that is being divided by 2, since we have this fraction bar here. It's really one big term. And speaking of terms, we need to get some vocabulary out of the way. When we look at this expression here, we have two terms that come at us at first. We have 3x to the fourth power, and then which is right here, and then we also have another term which is 2y. And see, a term in an algebraic expression is any number or variable or combination of variables and numbers that are separated in an expression by addition or subtraction. Now some of you might want to say, well, what about 2? Isn't 2 a term? Well, if it was in this expression and it was separated by addition or subtraction, yes. But when we take a look at this, there's a fraction bar here. So that's division. So we can't say that 2 is a term in this expression. Okay, let's take a look at some variables. Let me change my color here. Variables are symbols. That's what we're learning about today. Variables are symbols. They're often letters, and in this case they're x and y, and they represent some unknown value or quantity. So our variables would be x, and we also have a y right here. Those are our only two variables in this expression. And then coefficients. Coefficients are the constants or the numbers that are directly attached to our variables, not to be confused with exponents. For example, here we have an x as our variable, but it's how many x's do we have? We have 3 of them. So 3 would be a coefficient. And then we also have a 2 right here in front of the y. So we'd also have the coefficient of 2. It tells us how many of these variables. There's 2 y's, there's 3 x's. 3 and 2 are our coefficients. Okay, that brings us next to groupings. Now, somebody might say, well, I don't see any parentheses, and I don't see brackets or braces, so I don't think there's any groupings. But let's take a look at this expression more closely here. Since we have a division bar here, and we're dividing both of these terms by 2, okay, and it's actually the difference of these two terms, we kind of have to imply that what does this really mean? It means the difference of 3x to the fourth power and 2y divided by 2. See, we have to divide everything on top in this numerator here by 2. So technically there is a grouping here. We need to take care of the numerator first before we divide. Okay, even though that there's no parentheses up here, it's implied that 3x to the fourth power minus 2y, that's all in parentheses. So yes, we actually do have groupings here. They're implied. And last but not least, let's take a look at exponents. Now, what are exponents? We know what exponents are. That is when we have a variable or a number, and a number by itself or constant. And in the upper right-hand corner, we have a number that's floating. And right here, 4 is our exponent. So we do have an exponent, and that would be 4 to the fourth power. So there are some very important terms. When we talk about terms, we're talking about any constant number or variable or combination of the two that are in an expression that are separated by addition or subtraction. In this case, it's subtraction. Those are our terms. We have 3x and 3x to the fourth power and 2y. Our variables, we only have x and y, and then we have the coefficients of 3 because we have 3 x's and we have 2 y's. Do we have groupings? Yes, it's kind of tricky. You don't catch it at first, but since we're dividing this entire numerator here by 2, it's implied that 3x to the fourth power minus 2y, that's all inside these parentheses here. And then we do have one exponent. Our variable x is being raised to the fourth power. Boys and girls, let's solve this algebraic expression through substituting. We're going to substitute the value of x with 2 and y with 3. And see, this is what variables are all about. We have an unknown here, and now we're defining what that unknown is. Now, the first step of solving is simply rewriting our mathematical expression. We're going to take 3 and we're going to substitute x with 2, and I'm just putting parentheses there to emphasize that this 2 used to be the variable x to the fourth power minus 2 times y, and y is 3 now. And all of that will be divided by 2. Now, according to order of operations, what should we do first? We should take care of our exponent. Okay, we have an exponent right here, 2 to the fourth power. So this is going to become 3 times 2 times 2 times 2 times 2, which is 16, minus 2 to the third power. I bring down all the rest of my mathematical information. I want to keep track of it. I want to keep it organized. Okay, now according to order of operations, we should do multiplication and division. Well, multiplication comes first here, and as we look to, it's also inside the groupings. So we have 3 times 16, which is 48, minus 2 times 3, which is 6. And all of that is still going to be divided by 2. Okay, we're still solving what's inside these parentheses here, because we have to take care of the numerator before we can divide. Okay, so now we have 48 minus 6, which is equal to 42 divided by 2, and 42 divided by 2 is 21. And there you have it. Boys and girls, let's do one more sample problem together. Get out your PEMDAS and algebraic expression practice handout and go to number 6. Number 6, we have this algebraic expression where, well, let's read it first of all. It looks like we have, it's a mouthful. We have the quotient of 2 times the difference of 9 minus the sum of t plus 3, and all that's divided by 2, or divided by t, I should say, plus 2 to the t power. Okay, that's a mouthful, but if we take it one step at a time, it's not that bad. First, let's substitute. Let's get rid of our variables, t with 3. It says let t equals 3. So wherever we see a t, we have to replace it with a 3. So I'm going to rewrite this expression exactly the way it is, except when I get to my variable t here, I'm going to replace that with a 3. Okay, and already it's starting to look a little bit better. And that's all divided by t, and t is 3, so I substitute t with 3, plus 2 to the t power, which is 3. Okay, first step is we need to take care of our groupings, and we have this big numerator. Let's get rid of this big numerator. We work inside out. We have brackets here, and then we have parentheses inside, so we take care of the parentheses first. 3 plus 3 is 6. We copy everything down just the way it is. Don't forget any information. It's real easy when we're copying the information down to leave something out. We aren't done with the groupings yet. Now we have 9 minus 6, which is 3. Okay, I'm going to slide over this way now. Okay, just because I ran out of room down at the bottom. Still have to take care of this numerator here. Right now I have 2 times 3, which is 6, plus 2 to the third power. Okay, I'm done with my groupings. Next comes exponents, and I have 2 to the third power. And 2 to the third power would be 2 times 2 times 2, which is 8. So I have 6/3 plus 8. Okay, and now I have 6/3, which is really a division problem. We're getting close here. 6 divided by 3 is 2. plus 8, and our last operation is 10. And we did it. We did it. Okay, you try some on your own and have fun.
Boys and girls, I hope that was helpful. And just remember, when we're dealing with variables, variables simply are letters or symbols that represent unknown values. And those values can be given to us or we have to figure them out. I'll see you later. Bye-bye.